Welcome students. So after a few days we are back. Today we'll read about heating effect of electric current. Or we can say heating effect of current. It means, in general, if we can try to understand this, in general we can say that due to electric current, heat will be produced. So how heat is produced? Let us see. So we know that when a conductor carries current, suppose this is a conductor, these are the particles of conductor, and electrons or current is flowing or flow through the conductor. When the particles of the conductors or when the electrons or electric current flow through the conductor, what happens? Due to the collision between the particle of conductor or due to the obstruction offered by the particles of the conductor, the electric current decreases. Yes, the electric current decreases. So how electric current decreases? Suppose the electron is flowing in with a particular speed or with a particular velocity. When it gets collided with the particle of the conductor, its velocity will decrease, yes or no? When its velocity will decrease, its kinetic energy will decrease. Now according to the law of conservation of energy, we know that energy can neither be created nor be destroyed. It will be transformed from one form to another form, and the total energy in the universe or total energy of the body is always constant. That means when the speed of the electrons decreases, the kinetic energy decreases. This kinetic energy or this decrease in kinetic energy of the electron results the formation of a heat in the conductor. That means there happens the transformation of energy, that means from electric energy to, or we can say from kinetic energy of the electron to heat energy. So due to this production of heat, the conductor gets heated, and sometimes the conductor produces huge amount of heat. As a result, some part of heat energy is transformed or is converted into light energy. Is it clear? So the heat energy produced in the conductor depends on following factors. So on what factors they depends? First of all, heat energy is directly proportional to I square. It means when the electric current increases, the amount of heat produced also will increase. Means the heat energy is directly proportional to the square of electric current flowing through the conductor. This is number one equation. Number two equation, H proportional to R. It means when the resistance of the conductor increases, also the heat energy produced in the conductor increases. This is number two. And more, heat energy is directly proportional to T time. So how heat energy is proportional to time? directly proportional. Now see, let us take an electric iron and connect it to the plug socket. You will see, as the time will pass, suppose you will make the iron be connected with the electric circuit for 5 minutes. How much heat will be produced, or how much the iron will be heated? If more time will be more, suppose I will connect it for 10 minutes, obviously the time will be more, means heat produced will be more. So this is number 3 equation. If I combine these three, I can write H is proportional to I square RT, or I can say H is equal to 1 by J I square RT. So what is this? What is 1 J here? Here J is the constant of proportionality, and we can say J is called Joule's constant. And its value, how much? 4.2 joule per calorie. Joule per calorie. So this is the Joule's constant. About this you will read in 11th class or 12th class. Only remember this, J is the Joule's constant. Or if I will make J is equal to 1, I can write H is equal to I square RT for J is equal to 1. H will be equal to I square RT. This is the formula for the heat produced in the conductor or in the current carrying conductor. Okay. Now, my point is, where we will have the application of this heating effect. The first application is electric heater. In electric heater, we have a filament or we have a coil element that is called heating element. That coil is made up of nichrome, that means nickel plus chromium. This is alloy of nickel and chromium. The heating element of the electric heater is made up of nichrome, that is nickel and chromium. Why it is made up of nichrome? Why it is made up of alloy? Because the alloys give more resistance to the flow of current than metals. That's why we prefer alloy for the heating element, not metals. Clear? Number 2, geysers. Number 3, electric toaster. Number 4, electric bulb. In electric bulb, the filament is made up of metal tungsten. Tungsten is a metal which gives a huge resistance, a huge amount of resistance to the flow of electric current. As a result, it produces a huge amount of heat, and some part of the heat energy is converted to light energy. Clear? Okay. And next one is fuse. It is the main use of heating effect of electric current. We will read it afterwards. Clear? Now, I have told you that P is equal to VI, or I can say I is equal to V by P, no, P by V, I is equal to P by V, clear? Or we can say here I is proportional to P for constant V. It means if the voltage remains constant, if the power of the appliance will be more, it will draw more amount of electric current from the electric circuit. So we have to design our electric circuit as per the power of the electrical appliance to be connected with the electric circuit. We cannot connect a high power electric appliance to an electric circuit which is designed for very low power electrical appliances, because it will draw more amount of current from the electric circuit. As a result, there is chance of burning of circuit because of the production of heat, which we will read afterwards. Clear? So today is up to this much. In next class we will read about fuse and the application of a fuse, and if you have not subscribed my channel, just subscribe and like the video, comment in the video if you have any doubt, share the video to other students, that's why they can see and learn something in this pandemic situation. Clear? Thank you everybody.